Hello and welcome. Thank you for joining us for Building Accessible Ideas using UDL to help students learn to code. I'm Dr. Caitlyn Bukaty, and I'm the project director for Project RAISE. In this technology demonstration, our principal investigator, Dr. Ilene Wilkins, the executive director of UCP of Central Florida, will provide a brief overview of our funded project, its features and goals. Dr. Lisa Dieker will discuss STEM in the context of students with disabilities. Dr. Matt Taylor will give us a closer look at coding as a STEM task and share what we know about coding for students with disabilities. And Dr. Charlie Hughes will demonstrate our newly developed coding application, Raise Up. And I'll conclude by highlighting how Raise Up is based on universal design for learning.
I'm Dr. Ilene Wilkins, PI for Project RAISE. UCP Charter Schools, part of UCP of Central Florida, is the lead agency for this project. Originally United Cerebral Palsy, we just served young children with cerebral palsy, but have since expanded to serve children with all disabilities as well as students without disabilities in our inclusive charter schools. We now go by unlocking children's potential with a network of 8 charter schools in Central Florida. Project RAISE focuses on supporting students with disabilities in learning communication skills, coding, STEM content, and social relationship skills. We're working with various UCP charter schools as well as some additional partner schools. In Phase 1, students learn coding skills and receive communication coaching while building a relationship with the socially assistive robot, Zuby. In Phase 2, students share their new coding skills with a peer while Zuby supports them. And in Phase 3, Zuby provides personalized support in the classroom to allow students maximum support in the general education setting. We envision 6 different aspects of Project RAISE will be available as open education resources at the end of the project. Teachers and schools will be able to use these tools and resources in areas such as students with autism learning to code, students with ASD teaching a peer to code, socially assistive robot supporting students with ASD in math class, professional development on cooperative learning in math, professional development for teachers and paraprofessionals, and measuring social interaction and communication.
Thank you, Ilene, for a great partnership. I'm Dr. Lisa Dieker, professor at the University of Central Florida, where we are leading the research component of this project with UCP of Central Florida. In this project, as Ilene has shared, we're creating socially assisted robots to support students with autism spectrum in the STEM areas. What's exciting about this project is that we know students with disabilities are very much positioned to have some skill bases in STEM fields. Yet what we often see is they may not have the self-regulation, they may not have the support, they also may not have the exposure. So we're very excited in this project that the buckets of work that we're creating will provide coding support, helping paras understand how to do coding, and really very excited to think about how we might be creating these artificial intelligent robots, not to replace teachers ever, but to really elevate students' executive functioning, communication skills, and provide them with STEM support in that general education classroom. So we look forward to you listening to more of our presentation, but we're also very excited to share all of the resources we have and the great work that we're doing as a team. And so do keep in mind as you think about these resources, how can you, in your work in the field, really make an impact in making sure kids with disabilities learn coding, students with disabilities have equal access to high STEM content and high STEM dialogue with their peers, because we know the research data shows that students with disabilities are unemployed or underemployed in these careers.
While students with low incidence disabilities have historically been left out of research and practitioner reports with coding, new research in the last 10 to 15 years has begun to look more at coding and working with these same students. The importance of coding goes beyond just learning to move blocks and works into areas like problem solving, critical thinking, sequencing, collaboration, and designing tasks through active learning and engagement. Arguably all areas needed in living successful and productive lives. Coding for Project RAISE was developed to teach basics in the coding language using the programming app Blockly, created by Wonder Workshop and shown in the picture to the right. Participants first complete an introductory coding puzzle called Driving School, which teaches them the basics of dragging, moving, and lining up the blocks of code. Participants are then taught and guided by the AI avatar Zuby to sequence code to make the Dash robot move in a square. What we have discovered, and which will be discussed more in depth on the following slides, is that coding with Blockly can be confusing for the students. Blockly gives students freedom to choose from a vast list of commands and operations. This can be overwhelming and cause the student to lose focus from the main task. Movement of the blocks can be difficult as they need to be dragged with only one finger on the screen and placed in order. Blockly was also created for students with strong reading abilities, and those without the ability to read the words seen on the screen will find coding difficult. The pieces on the touch screen need to be moved in a sequential pattern. If the students don't see or understand that pattern, they will have trouble. So what can we do? We decided to try to make the coding language and options more user-friendly by limiting the amount of coding choices, adding cues to find the right blocks, and making sure that even non-readers can still participate. The new coding program is called Raise Up.
Welcome to a brief demo of our Raise Up system. It's an environment that is designed for young children, specifically the ones we're working with who are on the spectrum. And what we want to do is to reduce the cognitive load in them. So this is an environment for programming robots. It uses the Blockly system, which is an open source system from Google. And unlike some other environments for controlling the robots, it has very simple and configurable components that you can have in it. So first of all, let me just connect, and I'll connect to the robot. Now, once I connect, the connect button disappears, which is important because often the kids just keep clicking connect, and we don't want that to happen. Up here, this is a widget in which you put other widgets that you want to have to do some programming. And I'm going to take a repeat widget, which has a default of 4 times. We set that default. We can alter it by configuration files. We can alter which of these widgets are available by a simple configuration file to add things like changing the color of the robot and having it talk, etc. But right now, I want to just create a square. So I'm going to go forward. I'm going to go right. I want the square not to be quite that big. So the default value was 100 centimeters. I'm going to go with 80 centimeters. So now I will press the play button. The robot moves. Robot turns. Robot moves. Robot turns. Robot moves. Robot turns. Robot moves. Robot turns.
Thanks, Charlie. Now that we know more about the Raise Up platform, let's take a look at some of its universal design for learning informed features. Increasing the visibility of critical features, such as the widgets a student needs and the wastebasket, provides options for comprehension within multiple means of representation. By incorporating options to limit widgets, offer composite widgets, or automatically place widgets for students, we use graduated levels of support to provide multiple means of action and expression. By presetting default values for widgets that need them, we recruit student interest by minimizing distraction, providing multiple means of engagement. Finally, the entire Raise Up development represents optimized access to this learning tool with assistive technology built right in, paving the way for student action and expression. Thank you so much for joining our technology demonstration. You'll find our email addresses listed on the screen, as well as the Project Raise website. Please reach out with any questions or feedback. Thanks again, and have a great day.